let's look at an interesting set of graphs. So let's say we have a function which is conditional kind of thing. So if 0 is less than or equal to x, which is in turn less than or equal to 2, then x. If 2 is less than x, which is in turn less than or equal to 4, then minus x plus 4. Right? So this is one function we have. Now let's look at another function. If um, if 0 is less than or equal to x, which is in turn less than 1, then x. If 1 is less than or equal to x, which is in turn less than or equal to 2, then 1, else 2 is less than x, which is in turn less than or equal to 3, then uh, x plus 3. Let's see whether it x minus 3. No, not even that. Minus x plus 3. Right? So this is how it looks like. Now, let's change the color of this one. Usually it gives different colors, but I don't know. Now what we want to do is we want to flip it to the other side. Now what we'll do is we will put a slider, right? Minus 10 to 10 with a jump of say 0.1, and let's make it as t. Now what I'll do is I'll say g of t minus x. See what has happened? It has got flipped to the other side. Okay, so now I can hide this, and now what I want to be able to do is slide it. For that I just have to animate this. So now you see this graph goes slides through the first function, that is f of x. This is sliding over this graph. Okay, so what I'll do is I'll take the product of these two. So f of x times h of x, not like that, outside, times h of x. Right? If I do that, what happens? Do you see this small curve? And now let's animate this again. Right? Now watch this. Watch this. Right? So again, just so that you can clearly see it, what I'll do is I will change the color of this. I don't know why it is not using different colors. So let's say this is green. No, green is already used. Okay, here itself I have. So let us say, okay, this one. And now let's start it. Okay, now it will come. It's coming. Now let's see what happens. Yes, see? Okay, So now what we are interested in is the third curve that comes up when these two overlap. We want the area under that curve. So which means what? Integral of p of x, say from minus 10 to 10, right? And now let's see what happens. Yes. So naturally the intersecting areas, they initially increase and then they decrease. So the process of finding this area under the curve, which gets generated by the sliding overlapping of these two functions, that is called convolution. Okay, we can use different functions. Another thing you have to remember is that if you notice this area under the curve of the third, the convolution part of it, right, it never leaves this triangle f of x, right? uh, so the integral is always within this. Now why that is? Because f of x is 0 at every other place except between 0 and 4, or we can say it is undefined. So it is treated as 0 and the product becomes 0. So which means the curve goes to 0, the third curve, and the integral is 0. Okay, so we can try this with different functions. So let's slide a different function through this triangle. Okay, first let's hide these. We don't really require these now. Okay, we don't need to display this also, slider also. Okay, let's define a new function. So if minus 10 is less than or equal to x, which is in turn less than or equal to 10, then sine of t minus x, right? So we have got a sine function, which is a periodic function, right? Um, and it keeps going indefinitely in either direction. Okay, so this would be much more interesting. Let's say f of x times q of x, right? So again, if we start the animation, the product curve is this, but what we want is the area under that curve, right? So which means we need to take the integral of r of x from minus 10 to 10. Now what's the fun? Yes. So I'm sure you understand that the kind of curve that gets generated would differ if either of these two functions are different. Instead of this triangle, we have a different function, or if instead of sine, we have a different function. So the curve generated would be different, and the integral under that, the area under that curve would be. And remember, this process is called convolution. Or in other words, two functions f of x and in this case q of x are convolving with each other to produce a third curve, and the area under that curve is what we are interested in. More way of looking at this is you can treat this triangle, that is the original f of x, as the filter, and this sine as the input signal. So input signal goes through the filter and gets transformed into a third type of wave, right? So this particular convolution is very important in lots of different areas where signals processing take place. Okay, that's it. Bye.